Hello, today we're going to do section 1.7 on coordinate systems and more. In our text, we're going to talk about plane Cartesian or rectangular coordinate system and plane polar coordinate systems. Before I talk about Cartesian and polar, let me mention what is not a plane. Well, in order to represent a coordinate system, a three-dimensional coordinate system, we'd have an x, a y, and a z axis. And so you might have something in the plane would be in this area over here, and outside the plane would be up along the z axis. So that's why we have that word plane there for polar coordinate system. Um, these are standard conventions. In the Cartesian coordinate system, we'll have an x, comma, y, and you know what? I can do something here. I can have an x comma y, and in the plane coordinate system, it's usually an r comma theta. And the x and y tells you x is the distance of the point to the right of the origin, and y is the distance upward from the origin. So that is the Cartesian or rectangular coordinate system. And the plane polar coordinate system gives you r, which is the distance from the origin, the distance of the point to the origin, and theta, which is the angle counterclockwise from the positive x axis. So over here is the positive x-axis. R is the distance from the origin. And over here we've got x is the distance to the right of the origin, y is the distance up from the origin. So this here again is the origin. So the coordinate systems can be given in two different ways. You can have the same point here measured as x comma y. Let's say this is 5 comma 5. And if that same point were measured in angle, this distance here is square root of 5 squared plus 5 squared, which would be 5 squared root of 2, but I'll write that in a second. And the angle, since it's 5 up and 5 across, that's going to be a 45-degree angle. So that would be the same. This and this. Well, I should write r comma theta in there. Equals r comma theta. Those are the same point, but given this, it's the same point, but this is the point in Cartesian coordinates, and this is the point in polar coordinates. So let me tell you how to convert from the Cartesian coordinates to the polar coordinates, and then I'll tell you how to convert the other way. Actually, let me do polar to, I'm reversing my order. I want to do polar to Cartesian first, because this one is a little bit easier. It's pretty straightforward. Polar to Cartesian, you're given r comma theta, and you want x comma y. So x is going to be r cosine theta, and y is going to be r sine theta. And it's as simple as that. That is the how to get from polar to Cartesian. Now, if I want to go from Cartesian to polar, we will go x comma y, and this one's a little bit more complicated because you got different, this one had pretty similar formulas for both of them. This one is going to have a strange format. Polar, or the x, or the r, I'm sorry, r is going to be the square root of x squared plus y squared. And this goes with an old familiar equation called Pythagoras. The formula that Pythagoras is most famous for is the one that goes the x squared plus y squared equals r squared. If you've got a triangle like this, and the base is x and the height is y, and there's a right angle in here, and this is called the hypotenuse, then this formula holds. All I'm doing to this formula is taking a square root of both sides, the positive square root, because ordinarily when you take the square root you would get plus or minus over here, but I want just the positive value. So that is r equals x squared plus y squared, or square root of x squared plus y squared. Now the angle is going to look a little bit strange, but it is arctangent of y over x, and then there's a conditional, plus 180 if x is less than 0. So if x is greater than 0, we don't add 180. If x is less than 0, we do add 180. Let me show you why I'll show you why that's the case. Okay, I'm going out to desmos.com/calculator to show this arctangent of x equation, and you can see its domain goes from negative infinity to positive infinity, but its range goes from, I think you'll find this is negative pi over 2 to pi over 2, or negative 90 degrees to positive 90 degrees if we did it in. So let me draw our big coordinate system here and imagine different slopes being plugged into the arctangent function. This is an infinite slope. This is a zero slope. This is a negative slope. This is a positive slope. So what happens if we're at this point over here? We've got a negative slope, and our arctangent function is going to give us this angle, which is going to be somewhere close to negative 90 degrees. But if our point is over here, it's still going to give us this angle, which is negative 90 degrees. So we have to add 180 degrees to the result in order to get the correct answer. let's think over here. Well, if our point is here, we'll plug in the slope for y over x into the arctangent function and get an answer somewhere around 60 degrees. But if our point is down here, we plug the same slope into our arctangent function, and we still get 60 degrees. So since x is negative over here, we're going to add 180 degrees to it, and we're still going to get the correct answer then after we add 180 degrees. So that is the way you do. That is why you add 180 degrees if x is less than 0. There's a mention here about degrees versus radians. Make sure that your calculator is in degrees when you want to use degrees, or in radians if you're using radians. There is another option if you're in a situation where you have to have radians. Or your means of calculating only does radians or only does degrees, you can use this ratio. Pi radians is equal to 180 degrees. So you can use a conversion factor of 180 degrees over pi radians to convert from degrees to radians or from radians to degrees. Or you can find the setting in your calculator that lets you set which one you want to use. All right, example 1.9 has the Cartesian coordinates of a point in the xy plane are negative 3.5 meters, comma, negative 2.5 meters. They give 3 significant digits in both of these cases. And it says find the polar coordinates of this point. So in order to do that, I'm just going to say r, well, I'll put it on a graph first, or an approximately on the graph. 1, 2, 3.5, and negative 2.5. So it's right around here somewhere. So we can use that point to check our answer at the end. To get it, we'll go r equals square root of parentheses negative 3.50 squared plus negative 2.50 squared. And theta is going to be arctangent of negative 2.5, negative 2.50, it's y divided by x divided by negative 3.50. And then because x is less than 0, we will be adding 180 degrees to this, because otherwise we'll get the angle for a point up here. And we need to add 180 degrees to that angle to get the correct one. So, so let's first do it the hard way. Equals square root of parentheses negative 3.50 parentheses squared. You see how I had to put that negative sign inside the parentheses? Otherwise, it wouldn't give me the right answer probably. Plus parentheses negative 2.50 squared. And that gives me 4.30. Our angle, arc equals arctan, doesn't have arctan, atan. So atan, parentheses, we're going to go with negative 2.50 divided by negative 3.50, and we're going to add you know what? I'm going to add pi because I don't actually know how to set this thing to, there might be a way of setting it to degrees, but I'm not quite sure what it is right now. So I'm going to actually take that answer because instead of adding 180, I'm adding pi, and then I'm multiplying it by times 180 divided by pi. And I'm getting an angle of 215.5 degrees. So where is that angle? Whoops. So on the diagram, that's going to be here. That's 180, 215. 200, they just round it to 216 degrees in the text, and they give this as 4.30 meters. So that is the polar coordinates of that point. Let's do it the easier way. We've got x and y are negative 3.5 and negative 2.5. And I'm going to do r and theta, and it's going to be equal to square root of that number squared plus that number squared gives us 4.30, and then this one equals a tan, but this time I'm not going to use a tan, I'm going to use a tan 2 of this number y divided by, no, sorry, I got to give him, it actually tells me down here x num then y num, so x num comma y num. Remember that you're dividing y num divided by x num, but that gives negative 2.5. Let's multiply that by 180 over pi divided by pi, and we get it in the angles. Let's go ahead to make it match the other one. Let's add 360 to that, and we get the same angle from that. So it gave the negative close, which is, what did it have before? Let's go ahead and remove the 360. It had negative 144.4 or negative 144. That negative 144 is from here. This is 90. Negative 144 degrees going this way. So it's 216 degrees going, it's 216 degrees counterclockwise from the positive x-axis, negative 144. The negative, if I said negative clockwise, that wouldn't be right because it'd be like a double negative. I could say positive 144 clockwise or negative 144 counterclockwise. So that's why there's a negative 144 there. Okay, I've gone past 20 minutes. I'll have to wrap it up here, and I'll finish part B in the next video.